Hello and welcome to our talk about how we went from just building Kubernetes operator to becoming a platform team at Swisscom. So with me here is Lea Brühwiler. My name is Fabian. We're both DevOps engineer in the same team. Our team basically does cloud native automation for some parts of Swisscom. I think most of you already know Swisscom. It's the largest telco in Switzerland and an IT solutions provider. So our first customer internal to build this automation is the 5G core. So what is the 5G core? So on the left-hand side, you can see your mobile phone. When you want to connect to the internet, you connect to the closest antenna. From there, your data gets routed to the mobile data core and then out to the network. Now, maybe one detail, just because it says 5G on your mobile phone doesn't mean you're using the 5G core, because this is just the transport layer going from your mobile phone to the antenna. And the core, most of the time, it's actually still the dual mode core, so the 4G one, and we are now helping to fully automate this new Kubernetes-based 5G core. So let's have a look. As I said, it's Kubernetes-based. It consists of multiple so-called network functions. These are we get them as Helm releases. Each network function has its specific function, of course. So some of them manage your SIM cards, some of them manage your subscription. They check how much data you use. You'll see one more later. Now, in one development environment, we have around 2,000 pods. So that's one core. In our dev environment, prod is larger. So for this, we have 32 large servers where it runs on. And of course, we don't just have one core in Switzerland. We have 3 data centers Swisscom has, and in each we have one core. So of course, for redundancy purposes. Now, these data centers and the core, we need all the connectivity. So for this, I'll introduce the 5G DevOps network engineer. I'll call him a network wizard. And maybe some of you remember this network wizard. I'm not talking about that. I'm talking about this type of wizard, because he needs to somehow connect your phone to the internet. And yeah, it looks a bit like magic sometimes, I think. So what does he need to do? We want to deploy a new network function called UPF. That's the user plane function. This is basically the big router. So all your data flows through these pods and then gets routed to the correct destination. Of course, we have the server hardware at the bottom. Then we have the operating system, the Kubernetes layer, and then our 5G core deployment. So since there are multiple servers, we need connectivity, of course, between the servers. And we need connectivity outside. So there we have lots of routers, of course, all around Switzerland, and switches which need to be properly configured. Now let's go through the traditional approach in the 5G core, how a network is deployed. First, our 5G wizard creates the IP assignments. Basically, this is still done in Excel. It takes him around 2 days. He needs to define IP addresses, static routes, prefix filters, and all those types of things that you need, and make sure it doesn't collide, of course, with anything else in the network. Once this is done, he has to collect them in our IPAM system, our IP management system. In our case, this is Netbox. And he has to populate it in some seed files, which are then used in the next step with some GitLab pipelines to generate, for example, CRs and resources for MetalLB. So we use MetalLB for the connectivity between the clusters. And on the left-hand side, of course, we also need to configure all the routers and switches. Luckily at Swisscom, we have basically a network-as-a-service offering. So we have this interface where we can configure VLANs and networks and the static routes and everything. But this is a manual process, so it takes 5 to 10 days. And of course, once it's done, we need to test it. There were lots of manual steps. On the left-hand side, it's more on the Kubernetes layer. So from our vendor, we get testing tools, of course, within the 5G core, and on the right-hand side we use, for example, Landslide to simulate traffic. Now, while doing all these steps, there's a bit of a problem, because our 5G wizard needs to talk to the operating system people, to the Kubernetes layer, to the router people. Everyone has its own domain. He needs to understand everything. So a 5G engineer doing a new network looks like this. It's very complex, and of course it's a bit messy, and you end up having errors. So to summarize the pain points, he needs cross-domain knowledge. It's a manual process. And in the end, you have a static config. What if you want to grow something? What if you add a new network? You need to do everything again. So here came the new idea. We already have Kubernetes for the 5G core, so why not leverage this resource model, Kubernetes resource model, also for our network automation? The idea would be our 5G wizard just creates this high-level intent saying, I need one new network. This is the parent prefix. Please do everything. This is then read by our first operator. This operator then distributes the tasks to all the other operators for IP addresses, secrets, router config, DNS, certificate, and so on. And this is the plan. What do you think, Leah? Can we build this?
So let's look at the traditional way again. So imagine a 5G engineer would like to deploy a new network. So he needs to configure the router. He does this through this network-as-a-service tool. And in advance, he reserves the IPs in the IPAM inventory. So for this, he uses Excel, a manual UI, and then netconf to configure the 5G core deployments. So it's a lot of different tools. What if we put Kubernetes operators in between? So these operators would then take over the communications between all these different tools, and the engineer will use the Kube API to talk to the Kubernetes operators. So if he has the intent to deploy a new network, he writes this intent into a YAML file, and it will be reconciled by the Kubernetes operators. Like this, we achieved that the domain knowledge is hidden away in the Kubernetes operators. There's automation now, so it's faster and also less error-prone. And we have static we have constant reconciliation, so we can have a dynamic configuration. If you'd like to learn more about our architecture, you can find the architecture paper on CNCF, and you can also see which open source tools we used to build this. So let's imagine here you meet a wizard who offers you a magical potion. Would you be brave and try it out, or be concerned about side effects? So in a way, you could look at these Kubernetes operators at automation potions. So of course, first you need to gain trust in it. We started with a gradual approach. We first teamed up with colleagues who are interested in new technologies and defined the first use case with them. We shipped the first prototype very early so we can get feedback from them and iterate. In our case, we chose the deployment of the networks as a first use case, and other parts were still done the traditional way in the beginning, like configuring then the actual deployments. All right, so we have the first use case. Is everything ready?
Yeah, so let's go. It seems easy, right? Do you still hear me? Yes? Okay, sorry. So let's go. The only thing we need to do is write the YAMLs, the automation runs, and we have a healthy network. Seems quite easy, right? So let's look at, so we're done, right? So let's look at what YAMLs we need to write. For this, we look at the Go struct. So here you can see one secondary network. This is the type of network we use for the user traffic. We can see clearly defined documentation, validation. So let's start with netbox config at the left top. We need a configuration for the netbox. Let's have a look at this struct. In there we have tenant, IPv6, IPv4. Let's look at the IPv6 struct. We can enable, disable it, select the parent prefix, put the prefix length there. I mean, you can see I think it's not so easy to use yet, right? If we just give this like that to the users. And actually, we got quite some feedback on our first operators. So we tried to give them the operators, and this is the feedback we received. So I think, Leah, they don't want to use it.
Yes, so let's look at all the feedback we received. Analyzing them, we put them into 4 different groups. The first one, we kind of saw we don't have the time to test your stuff. And also, you cannot deploy a 5G core with GitOps because you'll also always do manual changes on the box. For this, to approach this concern, we made sure we do a gradual adoption. So we focused on use cases where the colleagues were really interested to try it and motivated to test the tools we built. And we also focused on use cases which we could automate with GitOps and where we could design it in a way that no manual changes on the box were needed. And after the first use cases, for example, the deployment of the networks was done, we could add more use cases like configuring the 5G core deployments. Let's go to the next point. So we got the concerns, how can I see which changes are applied to the cluster? Or we also had the concern that it was easier or more intuitive to use the UIs. So for this, we actually also introduced graphical UIs, and there are a lot of open source tools already available. I'd like to show 2 of them. One of them is the CRD wizard. It can show you all the information you get with the kube control explain command. So you can select one of the CRs here. You can see all the spec fields, and if there are structs, you can open them and see all the documentations. Of course, you need to document your CRD well, so you can see the comments here. The other tool we used is Headlamp. So it's a UI for your Kubernetes cluster. Here in this view, you see the event. And we find the map view very helpful. So you can see everything that's deployed on your cluster. Like here's a netbox deployment. And you can see the pods and also the services that are used for this deployment. And since we work a lot of CRDs, our team also contributed this custom resource checkbox, which allows you to see also the custom resource you have on the cluster. So if something's missing in Headlamp, you can still contribute it since it's an open source project. And it also allows to build plugins. In our case, we have built one which does not only show owner references, but also custom references. For example, if you reference a config map in one of your CRs. So these tools help new users to get onboarded on Kubernetes if they're not yet familiar with the CLI to use. The next point was, how can the users be sure that it actually worked? If they were faster before, and how do they know where the change is coming from? So with this design to use the Kube API to add your high-level intent, we already have traceability built in, since we have all the commit history in Git. So if someone applies a change, we will be able to follow it and actually see what happened. And also for the Kubernetes operator output, you're kind of flexible where it's written. So you could put it first also to Git before you apply to the workload cluster to configure the actual 5G core deployments. Then very early, this dashboard is from when our operators were freshly built. We also created these dashboards to see which resources we actually manage and if they're at the expected state. So this also helped us to convince the management what we can achieve with these Kubernetes operators. Let's have a look at the last concerns. Since we were working together with network engineers who were new to Kubernetes, they did want to know how they can start to work with Kubernetes. And they also used different tools before, like GitLab pipelines. And for them, it was easier first to use them. So we invested a lot in knowledge sharing to also learn what our Kubernetes operators need to do and to get feedback on them. We were always just a chat message away. So if there's an issue or a question about the operators, all the users can reach us. And we did regular check-ins with the users. Other initiatives were like a Kubernetes community of practice where engineers could sign up to a class where they could learn how they can order their own Kubernetes cluster and deploy their first apps. And we invited engineers into our team so we can learn from each other for some weeks. So to sum up, we focused on gradual adoption, introduced graphical UIs, observability and traceability, and we also did invest into knowledge sharing. So we actually did a lot more than just building Kubernetes operators. Was it worth it?
So yeah, like Leah said, we wanted to just build Kubernetes operators, and I think we built the whole system around it with these community of practices where we have regular workshops and we really try to upskill the other people. I think this was really needed. To answer the question if it was worth it, we can have another look at the graph from the beginning where we have on the left way the traditional approach, and now we can have a look on the right side. So basically, you need to create a high-level intent. This still takes some time, but of course way less because you only need to select the parent prefix. There's not going to be any IP addresses or something like that in there anymore. That's all covered by the low-level operators. So then you have the operators which read the high-level intent. In a few seconds, they create all the low-level resources. And then these resources, of course, need to be applied to all the backend systems. That might take a few minutes until all the routers and switches are configured, but it's fully automated. And of course, since we're in this Kubernetes ecosystem, we also use all the tools available there, such as TestCube for continuous testing, and of course, continuous monitoring using Prometheus and Grafana. So with this, you can see that we had some substantial gains. And actually, this slide is not one we did for today. This is a slide we already have internally since some time. As Leah mentioned, it's always important to show also to the upper level what you're doing and that it's worth it with these numbers. It makes them so you can continue working on Kubernetes operators. So how do you feel now? Would you use the operators? Our colleagues, I think they will. At the top here, you can see those actual snippets that they wrote us. I mean, on the left top, it's thanks to the colleagues for what we've built together in the past 1.5 years. With this, I want to highlight that it's something together. I mean, 1.5 years is long, and it's together. So we built that always in collaboration, of course, with the 5G engineers. They had to invest lots of time. We had to invest time. So it's quite a commitment. If you look afterwards at the other bubbles, you can see that they think it's probably worth it. On the left bottom, I'm convinced that we've saved a week or two of toil. On the right, now it took me less than 1 hour to create those networks, of course, the speed improvements. And they also were the first time we actually used the full automation. They were amazed that we created all the endpoints without a single error. So there was no error in the end. So this was also something new while having the full automation. Now, of course, not everything is finished. We're not done. Not everything is perfect. So on the one hand side, we still have manual steps on some points. Especially in telco, of course, there's some compliance things. Sometimes you need to approve something manually. So there we still have some manual steps. I mean, this can easily be done with automatic merge requests. So you just need to approve there and see the diffs, for example. But this is still something we need to see if we can further improve. We have lots of types of different systems. So, for example, some of our cloud native, they call them cloud native network functions, but most of them are maybe not that cloud native yet. So there's still some imperative steps. They want us to first, you need to configure this, then you set up the database, then you need to do this. So you always need to see how you translate these imperative steps then to a declarative way. I mean, our approach, of course, is just to do this a layer above. So a layer above, you have this declarative approach, and then you automate those manual steps. But there's still some that needs to be done. And I mean, there's lots of legacy protocols, like you saw netconf, that still need to be used. So you need to integrate all those systems in the cloud native world. And of course, Now there's also the push for AI, so we need to see where we can meaningfully use it, either for monitoring or also you start using it for the customers to help them create the YAML files. I mean, with MCP servers, so they can automatically create the YAML files even easier. So to summarize, again, I mean, the gradual adoption, I think, is very important. So now we continue with the next step. At the moment, we're working on now configuring the actual core. So we have the full end-to-end automation, observability, and traceability for the customers and also for the management. You can see what you're doing. Knowledge sharing sessions. So we've done multiple of these Kubernetes workshops in the multiple offices in Swisscom. I think they're very important. And of course, make sure usability is there. That means also make sure that the events, the status is properly reported. You really have descriptive errors, because this saves us lots of time, because it will happen that our customers mistype something, there's an error, and then they come to us. And if they know how to see the error, of course, they can fix it themselves often already. I want to highlight here that we started this in 2024. I mean, this talk is not very technical. We had lots of more technical talks if you're interested. So it all started at KubeCon in 24, where we talked about moving to the Kubernetes resource model. Now this is quite more common that people do this. We had a talk about our DNS solution, how we cloud natively manage our DNS, our netbox operator. So basically we open source the netbox operator. So this is one of the operators we open source because it's a general one. It's not specific for our use case, so you can find it on GitHub if you're interested. We had a talk at KubeCon last year about also, and this year also, what we have to do about 6G to change to be fully cloud native and declarative. And then there's a talk about SDC. So we use SDC. This is schema-driven configuration. It's basically also an open source tool built by Nokia and now also by Swisscom to configure 5G cores, but also switches and routers using netconf interface in a declarative way. I think that's a very cool tool. And this talk was also presented at KubeCon this year. Yeah. So we're still ongoing, and you can find those resources on our GitHub. You can also find the slides already, since there were very similar slides at KubeCon. If you didn't manage to scan the reference architecture before, then you can have a look more about our architecture, and there you also find the recordings of our past talks. With that, thank you for listening, and are there any questions?